Hello, and welcome again to this channel, Intellimaths. Today, we're going to move forward in solving problems relating to indices. Today, we'll be solving exponential equations. But, like I promised us, that we are going to start from the very basic problems and move forward to the advanced one. Now, let's get started. Look at the examples I wrote on the board. We want to apply the laws of indices that we treated in the last video. If you have not watched the video, go and watch the previous video that we made on indices. That is where we explain in details the laws, all the 6 laws of indices that we have. Look at this. We are going to apply the first law of indices here that says a raised to power m times a raised to power n equals to a raised to power m plus n. That is the first law. That's what we're going to apply here. So we will say 5 raised to power 7 plus 4. And that will give us 5 raised to power 11. So this is our answer for this question. The second question, we are going to apply the second law of indices that says a raised to power n divided by a raised to power n equals to a raised to power m minus n. So this is the law that we're going to apply to this second question. And we're going to have 9 raised to power 8 minus 5. And that will give us 9 raised to power 3. So this is the answer to the second question. And the third question, we are going to apply the third law of indices that says a raised to power m into bracket n will give us a raised to power m times n. That is what we're going to apply here. Let's check it out. That shows we're going to have 4 raised to power 3 times 5, and that will be equal to 4 raised to power 15. This is the solution to the third question. And the sixth question, sorry, the fourth question, we're going to apply the fifth law of indices here, which is called the negative index. So the law states that a raised to power minus n will equals to 1 over a raised to power m. So that is the law of negative index, like we've treated it in the previous video. So in that case, this will give us 1 over 6 raised to power 3. And when you solve further, you have 1 over 6 times 6, 36, and 36 times 6, 18, 19, 216. And this is our answer for this question. So let's move to the fifth. Oh, sorry. Let's move to the fifth question. So we're going to apply the sixth law here. That is the law of fractional index. The law states that a raised to power m over n will give us n roots of a into power of n. That is what the rule of fractional index. So that is what we're going to apply to this question. That means we're going to have 5 roots of 32. 32 raised to power 1 is still 32. That means 5 root of 32 now will give us 2. Because, let's check it out. 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 will give us 32. Now, the sixth question here, we're going to apply the same law we apply, which is the law of fractional index. Then we're going to have 3 roots of 27. Then square. Now, 3 root of 27 now will give us 3. Then raised to power 2. Then we have, because 3 times 3, 9, 9 times 3. This is cube root. Cube root of 27 will give us 3. 3 raised to power 2 will now give us 9. So that is that about the basic and simple questions you can come across in indices. Now, we're going to move forward to solving exponential equations. Now, look at the questions on the board. If you see that it's a little bit different from the other questions that we just solved. So it's very simple to find solutions to this problem. We're going to apply laws of indices as applicable. So let's get started. So look at this first question. We have 25 raised to the power of 1.5. The first thing you will do is convert this exponent into fraction, because as it is in decimal now, it's the same meaning as being in fraction. So in order to solve this problem easily, we convert this power to fraction. Don't forget, 0.5, 1.5 is the same thing as saying 1 plus 0.5, isn't it? Now, that means we have one whole number. 0.5 is half, that is 1 over 2. Then change this from a mixed fraction to an improper fraction, it will give you 3 over 2. That means we're going to have 25 raised to the power of 3 over 2. So here, we are going to apply the law of fractional index to get it solved. So we're going to have 2 root 25, then raised to the power of 3. So square root of 25 will give us 5, then raised to the power of 3. That is 5 times 5 times 5. And that is what? It will give us 125. So 5 times 5, 25. 25 times 5 will give us 125. Now let's move on to the second question. We have 2 raised to the power of 8 equals to 0.125. Convert this. What we want to achieve here to get this problem solved is we want to convert this expression into its index form. That is, where we're going to have 2 as a base and have an exponent. Now, what are we going to do? Then we're going to say 2x, 2 raised to the power x equals to, if you want to convert this into fraction, it will be 125 over 1000. Then we have, let's divide this. 25 we go here in 5 times. 25 we go here in what? 40 times. We still have common factor. 5 here will be 1, 5 here will be 8. Now, as you can see now, we can now convert this into the 1 over 2 times 2 times 2. Since we now have 2 raised to power x equals to 1 over 2 raised to power 3. If you apply the fifth law here, that is the law of negative index. This will now give us 2 raised to power s equals to 2 raised to power minus 3. Then 2 will cancel 2, then our x will now be equals to minus 3. What we're going to do here is this. 10 raised to power x equals to 1 over 10,000 can be written as 10 raised to power of 4. We apply the law of negative index to this place also. Then we have 10 raised to power x equals to 10 raised to power minus 4. 10 we cancel 10. We have x equals to minus 4. Now the 10th question here that I just erased says 25 raised to power x equals to 625. Break this down also. We have 25 raised to power x equals to 25 raised to power 2, because 25 times 25 will give us 625. This we cancel this, then we have our x to be equals to 2. So, yes, but before we go today, I want us to solve a question. If you look at this question closely, you see it looks a little bit tricky compared to the questions that we've solved previously. But if you look at it closely, you see it's giving us the kind of quadratic equation vibe. Look at quadratic equation structure. We used to have a raised to power ax squared plus bx plus c equals to 0. A is the coefficient of x squared, b coefficient of x, and we do have a constant. If you look at this closely, it looks similar to this, but it's a little bit tricky because it is not exactly like this, but we can make this equation to be exactly like this. All right, now let's do this. Applying one of the law, which is the third law, we can rewrite this 5 raised to power 2x, we can rewrite it to be 5 raised to power x, then bracket 2, then minus 26 into bracket 5x plus 25 equals to 0. Now we now have 5 raised to power x the same. What are we going to do? Let us assign variable to this 5 raised to power x here. So let's say let p equals to 5 raised to power x. It means in this equation, anywhere we see 5 raised to power x, we're going to put p. Then we now have p raised to power 2 minus 26p plus 25 equals 0. This is a quadratic equation. So we are going to solve this equation using the factorization method. I will make another video where I will explain quadratic equation in details and different methods that we can use in solving quadratic equation, including the factorization method, the formula method, which we call almighty formula, the completing the square method, and the graphical method. So I'll make another video on that. But in this case, we're going to use factorization method. So what does it entail? Look at the coefficient of p and the constant. Think about 2 digits that when you add it together, will give you the coefficient of p, and when you multiply them together, we give you the constant. Now, let's think of okay, 1 and 25. When you multiply 1 and 25, we give you 25, which is the constant. And when you add 1 and 25 together, we give you 26. But don't forget, this is minus 26, not 26 actually. So what are we going to do? It means we're going to, this is what will work for us. Minus 1 and minus 25. When you multiply minus 1 and minus 25 together, we give you plus 25. And when you add minus 1 and minus 25 together, we give you minus 26. So we now write these equations to be p raised to power 2, all right, minus 1p. Let me put it that way so that you won't get confused. Then minus 25p plus 25 equals 0. So let's put it this way. Let's group them together. What is common to both that are here? That is p. Then you say p into brackets. How many p are, when you bring out p from here, you have p. When you bring out p from here, you'll be left with 1. Now let's come to this second expression also. What is common to both? We have 25. Now, when you bring out minus 25, then you have p. Then you have minus 1. Then equals to 0. Now, these are the same. We pick one. Sorry. So we now have p, the coefficient, the ones outside, p minus 25 equals to 0. And p minus 1 equals to 0. Now, let's firstly address this equation. It means p equals to, when 25 crosses, minus 25 crosses is equals to sign to become plus 25. So let's go back here. We said p is 5x. Now let's bring in 5x back. Sorry, 5 raised to power x rather. Then we have 5 raised to power x equals 25, which will be 5 raised to power x equals 5 raised to power 2. 5 we cancel 5, then we have x is equals to 2. Now, the second expression, which says p equals to p minus 1 equals to 0. Then we have p equals to plus 1. When minus plus is equals to sign, it's changed to plus. Now let's bring in 5 raised to power x. Then we have 5 raised to power x equals 1. This is not the end. We need to get the value of x. Don't forget the law of zero index that says any number raised to power of 0 is what? 1. It means 1 here is the same thing as 5 raised to power of 0. 5 we cancel 5, then we have x equals to 0. It means in this equation, our x is equals to 2 or x can be equals to 0. That is the solution. As you can see, it's law of indices that we apply all through. So you can lay your hands on as many as possible equations. So if you experience any difficulties or you have any question, always reach out to us via comments. Comment your questions, or you reach out to us on our social media platform. We are on Facebook, we are on Instagram, and we are on TikTok at Intellimaths Pro. And subscribe to this channel and turn on the notification bell so you will not miss any updates. So see you in the next video. Thank you.